Welcome to lesson 3 of chapter 1. So this is 1.3 part 2, continuing on new functions from old functions. Today is a very quick lesson, very fast review of simply transformations of functions and reflections. So we had different types of transformations that you used all through Math 12. You had a whole chapter on them in chapter 1, and you continued to use them for conics, graphs of log and exponential functions, graphs of trig functions. Uh, Possibly when you did rational functions, if you did those, you might have used transformations there as well, potentially. But you spent a lot of time on transformations. So this is again something you should be comfortable with. So the first one is if you have some f of x plus c or f of x minus c, this is moving up, this is moving down. Okay. If you have f of x minus c in brackets, this was moving right. F of x plus c in brackets was moving left. If you have negative f of x, this is a reflection across the x-axis or a vertical reflection. And what that would look like would be something like if this is my original f of x, negative f of x would be like this. Okay. If the negative is inside the brackets in front of the x, this was a reflection across the y-axis or a horizontal reflection. And again, this would be something like if I had my original function over here, let's say, if I wanted to reflect this across the y-axis, it would end up over here. Okay. We also had expansions, compressions. A reminder that if you have your value in front of your function, this was a vertical expansion, and it was exactly how you see it. Okay, so this one here is a vertical expansion by c. So if it had a 5, you're going to vertically expand it by 5. And if it was in front of your function and it was a 1 over c, same thing. This is going to be a vertical expansion. You can also call it a compression by 1 over c. Now, with your horizontal values, these were counterintuitive to what you thought. So if it says 5, it's not an expansion by 5. It's actually a compression by 1 over 5. Okay, so this one is actually a horizontal compression by 1 over c. And if you had something like 1 over 2, that's actually a horizontal expansion by 2. So we'll go through just a couple refreshers of how to write your equations here. So for example, if I had a function f of x, if I wanted to translate this 2 units down and 3 units left, this would be y equals f of x plus 3 for 3 units left and minus 2 for 2 units down. If you wanted to expand horizontally by a factor of 3, this would be f of 1 over 3x and reflect in the x-axis In the x-axis is a vertical reflection, which means the negative goes in front. Okay? If you wanted to do a horizontal expansion by a factor of 4, this would be 1 over 4x. A reflection in the y-axis is a horizontal reflection, meaning the negative goes inside with the x. We aren't moving left or right, so that's all that's going to go inside the function, but we are going to translate 3 units down, which means your minus 3 goes outside the f. Also, a reminder, some of you might have gotten used to writing that translation down over on the left with the y. This is fine as well. And that's all. So you can pick some of the practice questions to try if this is fresh in your brain. If you either took, maybe you took it in summer school or in the most recent semester, and you're finding you're like, oh, this is fine. You might not need to do so many practice questions. But if you are finding that it's been a while, maybe it's been an entire year since you took Math 12, you might want to go through more of these questions today. And that's it. Super short lesson today. So again, if you need a bit more time for last day, then you can spend some time working on more problems from the composite functions and such.